My name is Ulysses, and this video is a demonstration of a project I've been working on. It's called Gaia, and it's a game engine written entirely in Rust. It lets you draw a three-dimensional model of the Earth using elevation data and satellite imagery. And then you can draw any sort of vector polygon data on top of that terrain. In this case, I'm using a data set from Natural Earth, which has all the countries of the world. So at a high level, here's how this thing works. I construct a quad tree, which is a sort of tree of tiles where children are higher resolution versions of their parents, using NASA satellite imagery and an elevation data set I got from the NOAA online. Now, thanks to a bug that is currently in this program at the time of recording this video, I can show you what this alone looks like. And so what's going on here, and why you sometimes get like flickering squares that appear and disappear at the edge of the screen, or when I zoom in and out, you'll sometimes get weird effects. That's because what's going on here is there's a main thread that has a cache of tiles and renders them onto the terrain, well, as terrain. And then there's a background thread whose job it is to take the camera and from it determine what tiles we'd like to draw, and then load them from the hard drive and then pass them off to the main thread, which will put them into the cache. So this scene here will actually will scroll infinitely east and west, which is pretty cool. Now, coming back to the middle of the infinite map, you can see the countries again. Now, what I'm doing here is I'm actually drawing polygons onto uneven terrain, which is actually pretty tricky to do. It's called draping. And there are a lot of solutions to this problem you'll find in the wild. A lot of video games need to do this. But most of these solutions don't work when you're dealing with pretty massive data sets, because there's a lot of really uneven terrain, and it becomes intractable to, for instance, try to calculate every intersection of every polygon with the terrain it's on. So instead, I'm using a technique called shadow volume polygon draping, which was first described by Schneider and Klein from the University of Bonn. It's got shadow volume in the name because it's similar in spirit to how most games today simulate shadow effects. The shadow volume approach uses the GPU stencil buffer, which is essentially a kind of screen size scratch buffer your GPU has, and it uses it to calculate if there's an unobstructed line of sight between the terrain and the camera. This approach gives you a pixel-perfect rendition of the world, and it lets you avoid any weirdness like countries that bleed in from behind a mountain or just like randomly disappear beneath the soil. Like, this is not a bug here. This is actually the ocean, and there's just mud out here. It's not like there's a problem with the edge. I won't go into more detail here about how exactly the shadow volume technique works. There's a link in the README if you'd like to hear more about that. But essentially, it gives you this pretty cool looking result. And this is definitely still a work in progress. Like right here, we got some performance issues. It's related to the fact that Korea has like a bajillion islands. But overall, it's like the main idea is there, and I'm pretty excited about this project. I think if you have a game you're thinking of doing written in Rust that you'd like to build off of from this, I've already helped you out a lot. And if you just want to like explore the world, stare at maps, I like staring at maps, then I think you'll enjoy playing with this guy. So yeah, thank you for watching and enjoy.